Okay. So the addition reaction of these alkenes with halogens. As you can see, one of the bond that will break and the chlorine atom attaches on both the carbon atoms. So we get this product where carbon 1 and carbon 2. For the simplicity, I am labeling these carbon atoms with the double bonds as carbon 1 and carbon 2, right? So each have chlorine atoms on it. So you can see from unsaturated form to the saturated form. And we call it halogenation. Why? Because it is an addition of halogen. Is it clear? So,
So this dichloroethane is just a form of alkane.
yes, it is another class of compounds because they have halogens in it. So, they are the members like this 1,2-dichloroethane. They are the members of a new series of compounds which are known as halogenoalkane, right? So we can say these are the derivatives of alkanes in which one of the hydrogen that is substituted by the halogen group. So we call them halogenoalkanes. Got it?
Yeah.
A new series of hydrocarbons or along with the halogens. Okay, similar reaction you can see here. What if we treat this alkene like this, ethene, which is a colorless compound? So when it reacts with the bromine, so what happens? As we saw in case of chlorine, so here now we have bromine atoms, one here, another here. So one of the double bond that will break and bromine goes to each carbon atom. So what should be the name of this compound? So definitely it will be 1 and 2. 1 comma 2 di bromo
Ethane. Yeah.
ethane. Yes. Okay, now this reaction has a very importance.
How do you write this in form of like molecular formula?
Its molecular formula will be simply C2H4Br2. It will be
Okay.
C2H4 and Br2. Is it clear? So that is
Yeah.
the molecular formula, that's a displayed formula. Okay, this reaction has importance in our chemistry lab work. Actually, the color of this bromine aqueous that is orange. When we get aqueous bromine in our lab, so it's a liquid state and its color is orange. When it reacts with the unsaturated compound like ethene, which is a colorless compound, so on reaction, the color of this bromine that disappear. So that means we can use this reaction for the identification between saturated compound and unsaturated compound. As you can see, if we treat this aqueous bromine here with an saturated compound like ethane, it's a saturated, no? Ethane. So the color of the bromine does not disappear. But when we treat this aqueous bromine, which is orange in color, you can see here with the colorless compound, which is an unsaturated, the color of the bromine disappear. So we can use this test for the identification of unsaturated hydrocarbons. Is it clear?
So we use bromine to test unsaturated hydrocarbons.
Yes, aqueous bromine, exactly. Why?
Oh,
Because the color of the aqueous bromine, that is orange, right? But when we react it with the unsaturated compound, which we are going to identify, so its color that will disappear. So that clearly gives us indication that the given compound is unsaturated. Is it clear?
yes. So colorless means that it's unsaturated compound.
Mm-hmm.
Okay.
And if the color remains,
Then
that
it's a saturated compound.
saturated compound. Exactly. Okay, similarly, there is one more test which is very important for the identification of these unsaturated compounds. So, two tests are important in our identification of unsaturated compound, right? Unsaturated compound. Now, one we have seen the bromine water test. We call it bromine water test. Is it clear? The reaction of an alkene with the aqueous bromine, we call this test a bromine water test because the color will disappear. So that gives positive indication of unsaturated compound. Now the second one is KMNO4 test. Okay, what is in this test? As you know, that KMNO4, which is acidified, I would say acidified KMNO4 test. Acidified KMNO4 has its own color, which is purple. Is it clear? So, acidified KMNO4 is purple in color. So, when we want to check whether the given compound is saturated or unsaturated, so what we do, we add this acidified KMNO4. So if the color of this acidified KMNO4 disappear just like bromine, so that means our given compound that is unsaturated. Is it clear?
Yeah.
If color disappear, right, that gives positive indication. Positive indication of unsaturated compound. Is it clear?
Yeah.
Okay, so these are the main reactions of alkenes, sorry. One, let's revise it. Reaction with halogens, right? Reactions with hydrogen. Which type of reactions alkenes are showing? They are showing addition reactions. Okay,
Yeah.
one more reaction that is very important, which will help us in our next chapter as well. Okay, what if I react ethene, which is unsaturated compound, with water? Okay, same type of reaction. One of the bond that will break. Is it clear? So water will also break. Hydrogen goes to one carbon and OH goes to another carbon. Is it clear? So let's say hydrogen goes to carbon 1 and the OH group that goes to the carbon 2. So what we will get, CH2 has hydrogen and CH2 got OH group. Is it clear?
So the hydrogen from this water will go to H2C, and then the
Yes.
OH will go to CH2.
Yes. So
Can you
you can
can you
see
like
here,
write the split formula?
sorry.
Can you write the split formula?
Yes, look at this. We can have displayed formula like this. This carbon has three hydrogen atoms, right? And this carbon has two hydrogen atoms, you can see, and the OH group. Is it clear?
Yeah, now it's clear.
Hmm. So this OH group is also a functional group of another class of compounds. All
This is
those
carboxylic acid.
no, 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 no. That only OH group is alcohols. A new series of compounds which are known as alcohols. Alcohols have OH group. So that means we can prepare alcohols from alkenes by reacting them with water. So we need heat. In this reaction, we need pressure. And this reaction is also very important because this compound, as we know, it is an alcohol. So the name of this compound that is, I would write here, ethanol. Is it clear?
Yes,
So we can also write down its molecular formula like this CH3 CH2OH. CH3 CH2 and OH, ethanol. Ethanol is very important alcohol which is used in for different purposes. For perfume industry, ethanol is used as a solvent as well. Okay, this reaction and the catalyst in this reaction, that is phosphoric acid. This reaction is also useful in our next chapter, which is related with alcohols. So we can use this reaction as a preparation method of alcohols. Is it clear?
yeah.
So we can use it for the preparation of alcohols. So let's summarize our discussion about these alkenes. Which two tests we can use? The bromine water test and acidified KMNO4 for the identification of unsaturated compound. If the orange color of the bromine water goes colorless, it is positive test for alkenes. If the purple color of KMNO4 acidified goes colorless, it also positive test for alkenes. Is it clear?
Yeah.
Okay, now look at this. These are the reactions which will be given in your book as well. So what we are looking into this, that is the removal of hydrogen. We discussed this one as cracking of ethene, isn't it? Cracking of ethene, sorry, ethane, right? In the previous topic. And now the chemical properties of alkenes, that is addition of hydrogen. Addition of hydrogen, you can see here, giving us ethene, giving us ethane. So this is also known as hydrogenation. Is it clear?
Yeah.
Hydrogenation. Okay, what do we call this type of reaction? The addition of water. That is known as hydration. Is it
So when
clear?
water is added to an alkene, it forms an alcohol.
Exactly. So the conditions for high temperature, high pressure, and a catalyst, which is phosphoric acid. So all these reactions are addition reactions. Why? Because you can see the two reactants giving us a single product. So that's why they are addition reactions. Is it clear?
Yeah.
Okay. Now Next, test for unsaturation. We can use this bromine water for a test. As you can see in this diagram, one of the test tube had a saturated compound and another one unsaturated compound. So you can see in the test tube B, the solution is colorless. So that means this was unsaturated. While A, the color remains. It means no reaction with bromine water. So that was saturated compound. Is it clear?
Yes.
Okay, so what happens in this addition of bromine? We get halogenoalkane, which is 1,2-dibromoethane. And they also gives alkenes uh, isomers. Yesterday we discussed about the isomers. What do we call these type of isomers? They are isomers because of the position of the double bond, isn't it? So
Yes, the
that's
positional.
why they are positional isomers. Is it clear?
Yeah.
Okay, now let's move on to the next. Another class of organic compounds, as I gave you a little brief introduction of this, that is alcohols. Actually, alcohols is a separate class of organic compounds which have a functional group OH group. So all those compounds which have OH group in it, they are known as alcohols. Or for the naming, we also name them alkanol. Okay, that is very important. You can see here the word alkanol is derived from the word alkane. How? The ending E of an alkane is replaced by OL. So this helps us for the naming of the compounds which are present, which are the member of these this class of compound. Is it clear? So
Yeah.
alkanol or alcohols have OH functional group. So it means they are derived from alcohols. For as you can see here, if I have this alkane, so the name of this alkane, that is methane, right? If its hydrogen that is removed by the OH group, let me write it like this: removing hydrogen, adding OH group. So that will give us a first member of this series. So the name
Methanol.
will be exactly the ending E replaced by OL, right? You can see here methanol OH group is present in this compound. Similarly, this one, you can see here ethane. If one of the hydrogen is replaced and the OH group is attached to any one, right? So not specific hydrogen, but any one hydrogen can be replaced by the OH group. So ethane will convert to ethanol. So as you can see, it is a displayed formula. So this will be its structural formula, isn't it? Right?
Yeah.
Okay. We can also derive its general formula. So what is the general formula of alkane? You can see here the alkane general formula is CnH2n plus 2, right? So if we remove one of the hydrogens, what will be the formula? Then its formula will be this one, isn't it? CnH2n plus 1. Why? Because
We're removing
one
one
of the
hydrogen.
Yes, we removed one of the hydrogen. And that one of the hydrogen is substituted by the OH group. So there is OH as well. So that's the general formula of these alcohols, which are also known as alkanol. Is it clear?
Yes.
Okay, now alcohols, they can be prepared. So what will be the next member? Let's say we have methanol, ethanol, then what should be
Propan.
the name? Propanol for 3 carbon atom, 4 carbon atom, butanol, 5 carbon, pentanol. Is it clear?
Yeah.
Okay. So you can see here, similar to the previous homologous series, you can see as the chain length, methanol, ethanol, propan 1-ol, and butane 1-ol. Why 1-ol? Because you can see the numbering starts numbering the carbon atoms where the OH group is attached. So 1, 2, 3, and 4, right? So that's why its name is propane butane 1-ol.
So the numbering starts from where the hydroxide is located nearest, right?
Yes, exactly. And remember
Okay.
one thing, we will not use the word hydroxide for this OH group because when you say oxide, it is negatively charged. So that is hydroxyl group, right? So there is a
Okay.
difference in this. Hydroxide has a negative charge, while hydroxyl, that is the OH group, functional alcohol's functional group, right?
Yes.
Okay, so they can show position isomerism, isn't it? How? Look at this. If we have this alcohol, so the carbon one has OH group. So its name is propane. And remember, ending E is replaced by
Oh, and
OL. So propane 1-ol. So similar to this, this compound is also possible because that is our longest chain of carbon atoms. So what should be the name of this one? That is propane.
two O.
Exactly. So they are isomers of each other. And what's the difference in them? The difference is of their position. So that's why they are called position isomers. Is it clear?
Yes.
Okay. So the general formula of an alcohols, we derived that CnH2n plus 2. Why? Because we derived them from an alcohols. So from an alkanes, CnH2n plus 2. So one hydrogen replaced by the OH group. Okay. So one of the member is ethanol. How many carbon atoms in ethanol? 2, right? So the rest are hydrogen atoms. So it's in uses that is also good solvent, dissolves many substances, evaporates easily, it's volatile. So as you can see in this diagram, we use this ethanol to kill bacteria and viruses. So sanitizer and wipes, it burns readily. So it is also a good replacement of petrol. Hmm?
So it is a fuel.
Yes, we can use it as a fuel. Is it clear?
Yes.
Okay, now after this, as we discussed how we can prepare ethanol. So we have seen this reaction in our previous discussion. Ethene reaction with water. Hmm? Look at this. In our previous discussion, ethene reaction with water. The addition of water, isn't it? This one. Ethene when reacts with water in presence of catalyst and heat. So one of the double bond break, and hydrogen goes to one carbon, OH goes to the another carbon. Is it clear?
Yes.
Okay, now let's see what next. So this is a method which we can use for the preparation of alcohol on industrial scale. So definitely this reaction for the preparation of an alcohol has some uses, hmm, some advantages and some disadvantages. So what is the advantage of this reaction when we use this for the production of an alcohol in industry? So it is actually a continuous method for the preparation of. We are introducing the reactants, they are reacting and giving us an alcohol in a continuous way,
Is
isn't
this
it?
for all alcohols like methanol, butanol instead of ethanol?
Yes, we can prepare those alcohols as well. For those, we have to use actually propene and butene, but they can give different products as well. So in our next A levels, we'll see how they will make different products along with that. So they give mixture of products. But
Oh,
ethanol give ethene that gives only one alcohol, right? And what is the advantage? No need of purification, only one product, isn't it? And this reaction is fast as well. So sometimes they ask a question in our exams, what is the advantage, right? For this method in the industry. Is it clear? It also has some disadvantages. Why? What's those disadvantages? Ethene is our raw material. So from where we get this ethene? So we get ethene from crude oil, right? As we saw in the cracking of alkane, ethene can be produced. So crude oil is a non-renewable resource. So it means after some time, the crude oil and the source of this ethene that will
run out.
that yes that will turn out, and definitely the whole plant is of no use because the raw material is not available. And secondly, the cost. Definitely we need to supply this ethene from the main source to the industry. So that's why it is a costly process. Now, tomorrow we'll discuss the next method of preparation of alcohol, that is by fermentation, right?
Okay, sir.
See you then. Take
Allah
care.
Hafiz.
Love you.